Welcome to this video on practical smart contract development. We will focus on two essential workflows: manual deployment using Remix IDE and automated testing with the Hardhat framework. Our lab roadmap is split into two assignments. First, you will deploy a contract in Remix to build intuition. Then, you will automate those same checks in Hardhat, creating a test suite that you can rerun whenever you modify your code. Assignment 1 uses the Remix IDE. Remix provides a zero-setup browser environment, making it perfect for quickly writing, compiling, and deploying your first contracts. To get started, visit remix.ethereum.org. Open the File Explorer to create a workspace and a new Solidity file. Always include an SPDX license identifier and a Solidity version pragma at the top of your file. Next, use the Solidity Compiler tab. Match your compiler version to the pragma line in your code. Click Compile, and watch for the green checkmark, which confirms a successful build. Now, navigate to the Deploy and Run Transactions tab. The Remix VM is our recommended environment for this lab. It provides a simulated blockchain pre-funded with test accounts, perfect for manual testing. Remix color codes your contract functions. Blue buttons are for reading data, while orange and red buttons trigger transactions. Try switching accounts to test access control restrictions. The Compiler tab also provides vital artifacts, your ABI, bytecode, and gas estimates. Familiarize yourself with these, as they are central to how your contract interacts with the blockchain. Use this checklist to ensure you have completed all steps for the first assignment, from setting up your file to verifying access control manually. Assignment 2 introduces Hardhat, the industry standard development framework. Unlike Remix, Hardhat runs locally via the command line and allows for fully automated scriptable testing. A standard Hardhat project includes a contracts folder for your code, a test folder for your scripts, and an artifacts folder where your compiled output is generated. Hardhat tests use Mocha and Chai. This code snippet shows how to write an automated test that deploys your contract and asserts that unauthorized withdrawals are correctly reverted. You can also write tests for events and custom errors. This example shows how to verify that a transfer event was omitted and that a specific custom error was triggered. Run your tests with the command npx hardhat test. You can also use the Hardhat Gas Reporter plugin to get detailed insights into the gas costs of your functions. If a test fails, examine the diff provided by the terminal. Remember to use async await for your calls to avoid common promise-related errors during your debugging process. To complete the lab, you must satisfy 3 deliverables: a deployed contract in Remix with screenshots, a Hardhat project with 4 specific tests, and consistent contract logic verified across both environments. Let's check your knowledge. First, identify which Remix button color indicates a view or pure function. Second, describe what the revertedWithCustomError matcher verifies in a Hardhat test. Next, what artifact does a successful compilation produce for your tools to use? And finally, what happens when you call an asynchronous contract function in a test without using await? This wraps up our lab on Remix and Hardhat. You have now moved from manual deployment to building automated test suites, completing the core development workflow for Unit 2.